In the runs test for randomness, the underlying concept is that if the number of runs is very low or very high, then the data is probably A, random, B, arranged in order from low to high, C, arranged in order from high to low, D, not random, or E, mutually exclusive. Before we look at our choices again to decide what it is, let's look below at the fundamental principle of the run test. It says the fundamental principle of the runs test can be briefly stated as follows. Reject randomness if the number of runs is very low or very high. And then it lists an example. There's only the gender sequences are female, 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 male, 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 male. And that's not random because it only has 2 runs. And the runs are very low. So it's not random there. Another example is the sequence of genders, female, male, female, male, female, male, female, male, female, male. And it's not random because there are 10 runs, and that's very high. So we reject randomness if the number of runs is very low or very high. So what it's asking is the underlying concept is that if the number of runs is very low or very high, then the data is probably, well, your answer would be D, not random. If the data were random, we wouldn't have a low number or a high number of runs. If the data were arranged in order from low to high, you don't know how the runs would come out. Or the same thing if they were ordered from high to low. So we are saying that the data is D, not random. D.